In this episode of Cube FM, we're joined by Mark Campora, who's a systems consultant with experience going all the way back to military grade C development, high throughput Java platforms, and cloud native architecture at scale. In this episode, Mark shares insights into platform decisions based on cost models, infrastructure utilization, cold start behavior, and operational overhead. We explore how Kubernetes scheduling, cluster topology, multi AZ deployment, and resource bin packing introduce non trivial complexity, particularly for services with variable load profiles. Mark contrasts this with serverless execution via AWS Lambda, covering invocation patterns, warm start strategies, runtime limitations like single threaded execution and no in function caching, and the effect of concurrency quotas at scale. If you're evaluating execution models, revisiting platform choices, or debugging infrastructure cost creep, this conversation offers practical clarity that you will find insightful. This episode of Cube FM is brought to you by LearnK8s. LearnK8s has been helping engineers level up their Kubernetes skills since 2017. This is done by offering courses that are instructor-led, 60% practical, 40% theoretical. These courses are given to individuals as well as to groups, online and in person. Students have access to course materials for the rest of their lives, and you can find out more information at learnk8s.io. Now, let's get into the episode. Mark, welcome to Cube FM. What are 3 emerging Kubernetes tools that you are keeping an eye on?
You know, I'm not a Kubernetes specialist, but this said, I keep an eye on all the optimization techniques. You know, the team where I'm working at the moment, they started to deploy Carpenter. So I'm looking at this as a way to optimize the usage of the infrastructure. I'm also looking at what AWS is doing with Fargate, you know, to run containers on Fargate micro VMs. So it's only 2, but yeah, that's what I have.
Fantastic. For people who don't know you, Mark, can you tell us about what you do and what do you do for work?
Yes, sure. I'm an independent consultant in technology. I worked many years for a big travel tech company, you know, processing millions of transactions. Then I created my own startup with a couple of colleagues. And at the moment, I'm working for a company developing a search engine for academic and medical content, articles. I'm helping them making sense with their architecture and roadmap. Yeah.
And how did you get into cloud native?
How did I get into cloud native? Yeah, that's interesting. Yeah, you know, the travel tech company I mentioned, 6 or 7 years ago, they decided to modernize their architecture. They wanted to move to the cloud progressively because they had a big data center, private infrastructure. And they didn't want to rewrite everything. The architecture was already a service-oriented architecture, let's say. So we picked Kubernetes as a way to repackage or re-encapsulate all the services. And we picked Azure as a public cloud provider. So that's when I discovered the public cloud and the cloud native initiatives. Yeah.
And what were you before cloud native?
Oh, I started as a C++ developer, you know, for military grade type of projects. Then in the early 2000, you know, with the boom of the internet, I became a Java architect, and all that without the help of Stack Overflow or Copilot. So I let you imagine that was another world. Yeah.
And the Kubernetes and cloud native ecosystem, it moves very quickly. How do you stay up to date with all the changes that are going on?
Well, I read a lot of blogs, newsletters, and everything. I don't have a favorite one. I would say at the moment I'm reading a lot of Medium articles. Okay, your video is also, or blog is also part of the mix, but I don't have any true favorite. But the real thing I'm trying to do is when I discover something interesting, I'm trying to spend time playing with it, writing a small prototype, because I need it, you know, I need it to truly understand how things are working. Yeah.
And if you could go back in time and share a career tip with your younger self, what would it be?
I would send encouraging messages. Yes, so keep learning, do it even more because that's a very rewarding part of the process or journey, and keep experimenting, trying new things, because this part is really exciting. That's what makes things interesting, and you grow doing that.
Completely agree. As part of our monthly content discovery, we found an article that you wrote titled Lambda or Containers. So we're going to dig into that topic a little bit more now. Kubernetes has been a popular choice for container orchestration, but we're seeing some organizations reconsidering their approach. What challenges are these organizations encountering with Kubernetes that are prompting this reevaluation?
So that's an interesting question. The company I'm working for at the moment, they faced difficulties with Kubernetes. That's why they started working with them. I started looking at their deployment, because they experienced multiple outages, stability issues, and they also experienced significant cost, running cost. So they asked me to look at, they started to question if it was a valid choice and if they should not move everything to Lambdas, AWS Lambdas or functions. So I've started to look at the details, Let's start with that's a practical example. Let's start with the complexity to illustrate a bit here. When you run Kubernetes deployments, you have a lot of non-trivial decisions to make here. You need to decide, am I going to run one cluster or multiple clusters? Am I going to, which instance types am I going to pick on the infrastructure level? And how many machines do I need, instances? Then you need to decide how you are going to spread these machines on multiple availability zones for availability, and so on and so on. You have all these decisions to take, which are non-trivial, and you can make mistakes, obviously. And to take these decisions, you need specialists. You need the learning curve is quite steep, so you need to find people who are experienced here. The operational overhead is important, I would say. So here is the complexity, in my opinion. For the cost, let's talk about cost here. The issue is that it's quite easy to pay more than you should, because you pay for the allocated or provisioned infrastructure, the machines you start, and quite often they are underused. And it's quite easy, because we can have pods and containers who are asking for a large minimum set of pods or instances, and which are idle most of the time, over provisioned. You have this bin packing issue on the machines, on the instances. There is always some spare capacity left on the instances, so you pay for this unused capacity. And all this is multiplied if you deploy on multiple availability zones. So you end up with a significant bill, and moreover, you allocate, even if the platform is allocating dynamically your resources, your traffic evolves all along the day, and it's difficult to find the right level of infrastructure you need, depending on the day, depending on the week, depending on the season. So voila, you have a complexity factor, you have a cost factor. So people started to question, hey, why don't we move to Lambda? And that's why I've started to look at it. Yeah.
Now, you mentioned Lambda functions as an alternative. For those out there who might not be familiar, could you explain a little bit about how the Lambda model differs from the container-based approach that's using Kubernetes?
Yeah, sure. With Lambda, you don't have to take care of the underlying platform. Yeah, you write your code, you package it, and you deploy it. And the provider, AWS in the case of Lambda, they take care of everything. Yeah, they take care of a lot of the burden. Yeah, they are going to provision the proper infrastructure. They are going to scale this infrastructure depending on the demand, the incoming request, and they are going to spread this infrastructure across availability zones, so it's reliable. Yeah, it stays available for you. All this for free between quotes when you pay for it, but you don't have to care about it. So that's a very efficient model or productive model, let's say, from a development and from an operational standpoint here. I think once Adrian Cockcroft said the you can deploy a complete application with AWS Lambda, the time it takes to decide how you are going to deploy Kubernetes here. So that's a good illustration of AWS. With Lambdas, we can go fast, and AWS is going to take care of many of the non-trivial decisions for you.
Now, an element that's very important here is cost, as it's a driving factor in a lot of these decisions. How does the pricing model for Lambda compare to running containers in Kubernetes, particularly for different usage patterns?
Yeah, sure. So with containers, you have to provision infrastructure or machines, basically, and run your containers on these machines. You pay for the machines, the time you provision these machines. With Lambdas, you pay for, it's a pay-per-use model. You pay only when the function is invoked. You pay a few cents for each call. If your function is not called, is not invoked, you pay nothing, basically. So this can be very cost-effective in some situations, you know. When I looked at my customer deployment, they had, like many other deployments, they had a test system and a live system, a production system. On the test systems, you know, the traffic was low, and they had more than 500 services deployed, microservices deployed on this test system. No traffic during the night, no traffic during the weekend, and no traffic during the day. When I compared what they were paying on Kubernetes and what they could pay with Lambda, the balance was really great. They could pay 3 times less on the test system. In production, the picture was more nuanced, you know, because some 80%, let's say, of these 500 services, they were mostly idle. So this one would have been more cost-effective using Lambda. But the remaining 20%, they were heavily processing traffic all along the day. Well, not during the night, but all along the day. And in this case, moving them to Lambda would have been more costly. So at the end, the comparison was balanced here, same cost. So the conclusion is, it depends. If you have a consistent and high traffic on a function, on a Lambda, well, it can be more expensive than a container. If you don't have, or if you have infrequent and variable traffic on your service, then the Lambda is more cost effective.
That's interesting because it seems that the cost benefits can vary depending on the use case. How does Lambda compare to containers in scenarios with more consistent high volume traffic?
Okay, I just mentioned this in the previous question. Yeah, actually, I covered it. Yeah, so for consistent traffic, containers is more effective. There are other scenarios, you know, where Lambdas is not necessarily appropriate. If you have a need for high computation, you know, GPU, CPU, and you need to burn a lot of computation power, it's probably more effective to use containers and control the underlying instances you are using. Control better. There are also, with Lambda, you have this, you know, the execution environment. They are started on demand when you need to process a request. And you face what they call a cold start issue. If when you launch the environment, you have to wait a bit. And if your application or the function is complex and you embark a lot of libraries, that's a lot of things to load at startup time. So you might have a very, let's say, variable latency on this function and long response time. So if you don't want to have that, you want to have a very predictable and constant response time, Lambda is probably not the right solution here. I'm thinking about, trading applications where you need to answer very quickly and with a constant response time. Lambda is maybe not the best solution in this case.
Lambda functions operate within AWS's shared infrastructure, which likely comes with some constraints. What limitations or quotas should developers be aware of when using Lambda at scale?
Yeah, that's an interesting one. When I looked at the details here, by default, the Lambdas, they are running and scaling inside a region. Region is a unit of infrastructure for AWS. So you are using all you are using all the available capacity in this region. But as many customers are working in this same region, they try to make sure that there is a fair distribution of the capacity and you do not blow out the region here. So they protect themselves. So the first quota you are facing is, by default, in your account, you cannot launch more than 1,000 execution environment for a given Lambda. So meaning that as soon as you reach this limit, you will start queuing requests in a queue, waiting for an available execution environment to process it. This quota is negotiable. You can ask them to extend it easily. But okay, that's the first limit. First quota, sorry. I should pay attention to my words here. The second one is a limit, i.e. it's non-negotiable. And even if you ask for more, you have 2,000 execution environments for a given Lambda, you cannot allocate more than 1,000 during a window of 10 seconds. So that's a way to protect the region. If you have a surge of traffic, they are going to let you allocate 1,000 instances immediately, but then you will have to wait 10 seconds to allocate more. So voilà, that's the second limit that you need to understand, because if you have a very successful application with a lot of traffic coming in, you might face exceptions or timeouts, and you need to understand that it's because you're throttled in a way, i.e. AWS is going to reject or queue and reject some requests to protect the infrastructure. Sorry, that was a long answer.
It's okay. It's a long one, but a good one. There are a lot of things to keep in mind there. For teams that are out there that are considering migrating existing applications to Lambda, what key factors should they keep in mind during this process?
Yeah, it's quite, I know that was the second question from my customers. Yeah, can we migrate the existing microservice to Lambda? So I had a look, and it's a non-trivial project, I would say, with a lot of risks. It's quite easy to adapt your services, so they appear as a Lambda, and you can redeploy them easily. You can adapt your CI/CD pipeline to redeploy them. The main issue is that you are changing the execution on the runtime model. So, for instance, as the Lambdas can go up and down very quickly, you cannot use caching inside your function. You cannot cache anything in your. It's not going to be reliable. You cannot use multi-threading. The Lambdas, they are supposed to process one request at a time. So if you started using multi-threading, you have to change your code here. And I mentioned it. You have this cold start issue. So if you have, it's particularly significant with Java services. Java, the JVM is quite slow to start, and you load a lot of libraries. So if you don't pay attention to the startup of your Java function, you might face very unacceptable cold starts. The AWS, they released, a feature to optimize this aspect. But the point at the end, the bottom line is that migrating existing microservice to function requires effort, because you need to test them, you need to transform them, you need to rewrite them potentially. So it's not an easy task. Yeah.
In other conversations that we've had, we've given a lot of focus and attention, primarily to AWS Lambda, but there are other serverless function services that are available out there. How do offerings like Cloudflare Workers or Vals.town or Azure Functions compare to AWS Lambda?
I'm not, so I didn't play with them, so it's going to be just a theoretical position, but Azure Functions and the equivalent on the Google Cloud are very similar to AWS Lambda, one-to-one. When I looked quickly at Cloudflare Workers, I think they compare more to CloudFront Functions. i.e. Cloudflare, it's a CDN, a globally distributed network. And I think that what they offer you with workers is the capability to run your function very closely to your end users to reduce the latency. So that's a great idea. You can push part of your logic close to your user, so they don't have to cross the world to connect to your servers. That's a great idea, but there is a trick. You cannot really replicate your backend application all around the world. Yeah, so it's only part of your logic that you can push.
Some have suggested running Lambda on Kubernetes as a way to get the best of both worlds. What are your thoughts on this hybrid approach of combining Lambda with existing containerized services?
It's probably an interesting approach, for the bin packing issue, for the idle capacity which is left on the instances, because it will be easier to use this capacity, unused capacity. But I think, in my opinion, you miss the point if you do that, because you still have to take care of Kubernetes. The complexity aspect. You still have to deploy it correctly, size it correctly, operate it correctly. My opinion is that it's probably better to blend both architectures or mix both architectures. I have a Kubernetes deployment with a few services which require containers and Lambdas using the native environment, the AWS or Azure environment, to operate them. The only thing you need is a good level of abstraction, so you don't know actually if it's running on Lambda or containers or Kubernetes. So service bus or service mesh, which is agnostic. Yeah.
To conclude our discussion, Mark, could you summarize the main advantages of Lambda and identify the scenarios where it might be the most suitable choice for development teams?
Sure. If you start a greenfield project and you are not so sure about the market fit yet, you don't know yet how much volume you are going to process, consider using Lambda. That's a very productive development and operation environment. It's very cost-effective for this type of projects because you are going to process only a small amount of traffic at this time. And if you succeed and if you scale, then you will have only to rewrite 10 or 20% of your functions to optimize your cost. Yeah. So I think if you start a project, wow, go for it.
What's next for you, Mark?
At the moment, I'm looking at data platforms, the Lakehouse buzzword. I'm helping my customer to modernize its data platform. So we are looking at ways to create and share data sets using open table standards and so on.
And what's the best way for people to get in touch with you?
So I'm available on LinkedIn. That's my main communication platform, I would say. I usually come back very quickly to people who contact me. So do not hesitate.
Very good. Mark, thank you so much for joining us today. Hope our paths cross in the future. Take care.
Thank you. Bye-bye.